Welcome back to my YouTube channel, Massa Tutorials, where mathematics literacy begins. Alright, so now we are still started with another course, which is Further Calculus, Math 203. That's level 200. Level 200 course. Now, we want to solve sample questions on that. That's Further Calculus. That's question 1a. We have what? Sorry. Find the domain of g of x equals log of base 5, of x plus 1 over x. Find the domain of g of x equals log x plus 1 over x base 5. So how best can we solve this? So now let's proceed. Now, let's see. What's the meaning of domain? What's the meaning of domain? Domain refers to what? It isn't all the x values that will make this function what? Undefined, right? It excludes all the x values that will make this function undefined, which means it does not what? Exist. Then it would include all functions, all x values that will make this function what? Defined. That will make this function defined. So g of x means this function is in terms of what? X. Is in terms of x. So it means that now what's something here? If you have log 0, which means that the base is what? 10, right? Now log 0 is 10. Now what was the answer? Log 0 is 10. You can punch log 0 is 10. Or first of all, let's see. We equate that to what? X, right? Now this function we change it to what? Indices so that we can solve. So I write this 0, which must be equal to 10. This base 10. Then we raise this guy, which means that this guy becomes what? The exponent. So I get 0 equals 10 to the power x. Now what will be the value of this x? Now let's see this 0. Can you change this 0 as a base of 10? This 0 as a base of 10, which means no, there is no number. There is no number, which means that that's why what? When you punch log 0 base 10, it gives you what? Not error, which means there is no number or does not exist, right? So now let's proceed. Let's proceed. Let's proceed. So how can we find for the domain, which means that we are looking for the x values, the possible or all the possible x values that will make this function what? Defined. Domain refers to all the possible what? X values that will make this function defined. Alright, so now we just take the fraction or the fractional expression inside what? The bracket. So which is x plus 1 divided by x. In which we will make sure that what? It must be greater than what? 0. It must be greater than what? 0. So x plus 1 over x must be greater than what? 0. Which means that if this guy, when you write 0 here, it means that this, the whole of this function, the g of x, will be what? Undefined. So now, how do we solve for this x here? We have a denominator here, and how many terms? 1, 2. So we have to multiply each term by what? The denominator, which is the LCM. This one is divided by 1. So our LCM is what? X. So I have x times x plus 1 divided by x greater than 0 times what? X, right? So this guy cancels that. So I have x plus 1 greater than 0 times x. We obtain what? 0. Now x plus 1 greater than 0. I can solve for the value of x. Plus 1, we transpose that, which means that it crosses this inequality sign. So I get x greater than 0 minus 1. So I get x greater than negative 1. So x greater than negative 1, which means that x greater than negative 1. Let's see. Let's see. We don't want to conclude yet. Let's see. Our number line. We have our number line like this. I have 0, negative 1, negative 2, negative 3. Then I have 1, 2, 3. Right. Now, greater than x must be greater than negative 1, which means that this guy is not included. So this guy is exempted. Or we draw a circle, which means that we don't shape inside because of the greater than. Alright, so now let's see something here. Now, if you put negative 1 inside a function, now if you are finding for the domain, make sure that you test. When you are done solving, make sure that you test into the function. Just take values at the right hand side of this 0, then you take values at the left hand side of this 0, and also take the 0 to the neutral element and see whether you get defined or undefined. Right. So now let's see. We take negative 1. Let's try negative 1 plus 1 divided by negative 1. Negative 1 plus 1, you get 0. Divided by negative 1, you still get 0. So it means that log 0 base 5 is what? Undefined, which means if you substitute negative 1, this element, inside the function, this guy will go to what? Undefined, which means that this guy will not what? Exist. The function g of x will not what? Exist. And we don't want that. Domain, they are all the possible values. They are the possible values of this g of x, which will make this function what? Defined. That's what we are looking for. So now, negative 1 is exempted. Let's try 0. So we have 0 plus 1 divided by 0. You get 0 plus 1, which is what? 1 divided by 0. This guy is off. 1 divided by 0. 0 times 1 to give you 1. You don't know. So there is no number. There is no number. 0 times 1 to give you 1. There is no number. So it means that this guy too is what? Does not exist, which means it's undefined. So 0 2 is what? Excluded. So we don't shade inside. 0 2 is excluded. Let's see 1. Let's see 1. 1. When you substitute 1, which means 1 plus 1 divided by 1, I get 2 divided by 1, which is 2. Which means that 1 2 is what? 1 will make the function defined. 2 2 will make the function defined. 3 will make the function defined. Right? Okay. So it means that x is greater than negative 1. There are two elements here, which is negative 1 and 0, which will make what? When you substitute inside the function to make the function undefined. Only 2 elements, not all the elements. Only 2 of the elements. Negative 1 and 0. If I substitute in 100, the function will still be what? Defined. If you substitute in negative 1 and 0, the function will go to what? Undefined. So it means that from 1 to infinity, positive infinity, all the values of x, when you substitute the values of x, which is from 1 to positive infinity, it will make the function defined. So now let's see. We've substituted what? 0 inside already. So now let's try negative 1 is inside. We've done that. Negative 2, let's see. Negative 2 plus 1 divided by negative 2. Negative 2 plus 1, we get 1 divided by negative 2, we get 1 over 2, which is 0.5. Right. Now, which means that negative 2, when you substitute in negative 2, still the function would exist. It exists. So negative 2 to make the function exist. What of negative 3? Negative 3 plus 1, you get what? Negative 2 divided by negative 3, you get 2 over 3. So it means that from negative 2 to negative infinity, to make the function what? Exist. To make So these are the two values that will make the function what? Undefined. These are the two values that will make the function undefined. So how do we write our domain? So always when they ask you to find for the domain, when you are done solving, don't be in a hurry what? Don't be in a hurry what? To conclude that this is the domain. No. Just take the values of x. Draw your number line, just take the values of x, then you just take one after the other into the function. Just take two values from the right of 0, then you take two values from the left of 0. Then you can take the neutral element, which is 0. Then you can test it into the function and see whether the function will exist or does not exist. Don't forget, when you get the domain, make sure you don't be in a hurry to conclude. Don't be in a haste to conclude. Please, just take time. So now, with this, I can conclude. I know that my domain, I can say that my domain, or I can write it as that my domain will be equal to what? It opens negative infinity. Then now, negative 1 is not included. So I open, right? Union. Now, we can start from 0. You can open 0. Or if you want to start from 1, you just close using that, right? If you want to start from 0, you open. If you want to start from 0, you open, which means that 0 is not included. This one is open bracket, which means that 0 is not included. So, and also if you want to start from 1, you use this guy, which is close bracket. Then 1 is included, then comma, positive infinity. So I open positive infinity. So this will be our domain. So always check it very well. So I open on what? Negative 1. Then I open on what? Negative infinity. Which means that I've opened on negative infinity means that I allow all the elements, which means what? Negative 2, negative 3, negative 4, they are all what? Included. When you put the x values, those x values or the values of x inside the function still what? Exist. Right, so I've opened down to what? Negative infinity, which means all the values of x are what? Included. So you can go to another book, they can write the domain as negative infinity, then negative 1, union, it will open on 0. So don't forget, it will open on 0. Then it will open on positive infinity. So kindly check this and that. This one is closed on 1, which means that 1 is what's included. 1 is included. Right. So that means if I open on 1, which means that 1 is what? Included inside. Right. So if I close on 1, it means that what? 1 is what? Included. But if I open on negative 1, it means that negative 1 is not included. So take note of that. So now, so you can write your domain as that. Or this one. They are also domain for that. Or we can use the set builder notation. Domain must be equal to. So let's see. I can start x is such that x is a member of the real numbers, right? X must be the member of all real numbers. Now, let's see. X must be greater than, let's see, must be greater than 0. And also x must be, so So here I can say that x must be greater than -1. Let's see for this one. So if I have -1 less than x, it's the same thing as x is greater than -1. Okay, x is greater than -1, which means that 0, 1, 2. No, which means that 0, 1, 2. No, then we have to use this guy. We have to use this guy. Yes, we have to use this guy. I'm writing this for that. This -1 is greater than x, which means that x is less than -1. X is less than -1. If you have -1 greater than x, it's the same thing as x is less than -1. Which means that this guy, -1, is not included. It starts from what? It starts from -2, -3, -4, -5, -6. Right? So if you see this one as a set builder notation, so I have it x is such that x must be an element of the real numbers where my x must be what? Less than -1 but greater than what? 0. So you have it as that. So we have it as that. So if you get something like this, you can do that. You can do that. So if you want to draw the number line for this guy, let's see. Let's draw the number line for this guy. So I have something like that, which is 0, 1, 2, 3, -1, -2, -3. Right. So I want the number line for this guy. -1 is greater than x. If you are reading it like this, x is such that x is an element of the real numbers where x is what? Is less than, not greater than. I'm reading it like this, right? But if you want to read it like this, x is such that x must be a member of the real numbers where -1 is greater than x. If -1 is greater than x, which means that what are the elements? -2, -3, -4. So it points to this place. So always don't be looking at the arrow. There are some students, they always look at the arrow, then they just point it to the right hand side. No, just listen. They say -1 is greater than x. What are the elements greater than x? Which is what? -2, -3. -1 is greater than a number. What are the elements? -1 is greater than -2, -3, -4, -5, -6. Now, this one, x is greater than 0. So I have this one. So we have that. So we have -3, -2, -1, 0. So x is greater than 0. We start from what? 1, 2, 3. So then that means a number is greater than 0. A number is bigger than 0, which means that 1, 2, 3 up to positive infinity. So we have this. So it's the same thing. So either you can use that, which means I'll bring my 0 here. Then you are cool to go. You are cool to go. So here we can list the elements here. So if you are listing the elements, you bring your 3 dots, which means that we have more elements. The negative numbers, more of the negative numbers are here. So -3, -2, -1 is not included. Why? Because we shade inside. 0 is not included, so I start from 1, 2, then it continues. So if you want to list the elements, list the elements. We start from 3 dots, -3, -2, 1, 2, then it continues. Very, very simple and very, very trivial as well. I believe the explanation is working. Always take note. Don't forget. Always, if you want to find for the domain, when you solve for x, make sure that you test the values inside the function. Test the values inside the function, and you would rest assured that okay, these are the x values. When you put it inside the function, it will make the function what? Undefined. When you put it inside the function, it will make the function defined. All right. Thank you very much. Let's move on to question 1B. All right, question 1B. It says what? Find the integral of the function given as the integral e to the power x, square root of 1 minus e to the power x dx. So what here? We have this known as what? The indefinite integral. Indefinite integral, because we have no limits here. We have a limit here, which means that we get what? The definite integral. The definite integral. Now, integration, we are doing integration, which means that you want to find for the area of a curve, the area of a plane shape, the area of a solid figure. So integration is very, very good. It's very, very interesting as well. So now we are integrating this function. This function is known as the integrand. So we are integrating this function with respect to x. So it means that if you don't see any x inside, then that means you treat that value or that variable as what? A constant. That's what you have to listen. Now, again, we are integrating this function with respect to what? X. With respect to x. With respect to x. That means if you see any variable or any value apart from x, that value or that variable is a constant. You don't talk about that one. So you bring it outside, which means I'm not dealing with you, I'm dealing with what? X values. Those who are having x beside them. Alright, so now let's see. Now, this integration, how best can you solve this integration here? So now, then, if you want to solve this integration, you have to use what? Using U substitution or the substitution approach. So now, using the U substitution. Using the U substitution method. So now, we are using the U substitution method. So I let my U be equal to what? 1 minus e to the x, which means 1 minus e to the power what? X. So now let's let U be equal to 1 minus e to the x. So we have this. Now, your U is equal to 1 minus e to the x. What can you do again? You have to differentiate this U with respect to what? X. So now we differentiate U with respect to x, which means that I get, now we have two terms here, right? So we have to differentiate this guy, and also we have to differentiate that guy. So I have dx of what? 1 minus dx of what? E to the x. So we have this. So now, du over dx must be equal to, now, if we are differentiating a constant with respect to x, is 0. Because I have 1. Now, there is an x value here, but x value was the power. It is 0. And now, how do we differentiate? X to the power n, which means that I drop this n. So I get n times x, right? Then we subtract 1. So this one to the same thing. We drop the 0. So I get 0 times 1. Then we subtract 1. Now, 0 times 1 times this, the whole of this becomes what? 0. Don't forget. So the whole of this is 0. Minus, we are differentiating an exponential function. How do we differentiate an exponential function? What here? If I have, let's see, e to the 2x, so e raised to the power 2x, or e superscript 2x, or e raised to the power 2x. How can we differentiate that? So now, we differentiate the exponent, then we multiply the one you differentiated by the whole of the exponential function. Watch here. So I differentiate 2x. Now if you differentiate 2x, you get what? 2, right? Which means that this one is 1. It comes down. So I get 1 times 2. Then I subtract 1. Right? So I get 2. So then that means I use this 2 to multiply the whole of the exponential function. So I get 2 times e to the power 2x. Then 2 times e to the power 2x, I get 2 e to the power 2x, which is very, very simple and very, very trivial and very, very interesting as well. So now I have the x of e to the power x. Now, if you differentiate this x is to the power what? 1. So if you differentiate x to the power 1, you get what? 1. Because you subtract and this guy comes what? Down. Right. So x raised to the power 0 is what? 1. Now, so I get 1 times, I said we multiply it by what? The whole of the exponential function. And 1 times e to the power x is still what? E to the power x. So I get minus e to the power x. Then 0 minus e to the power x was the answer. So I have du over dx equals 0 minus that we get negative e to the power x. So we have this. Can you watch it carefully? My board is very small, so clean it. So can you watch it carefully and understand the procedure? So now let's proceed. We are using U substitution. So if you are using U substitution, this is how we go by the U substitution. Now, we are using U substitution. So this dx, we have to make what? Dx the subject here. Because we want to change all these things to become what? In terms of what? U. That's why we call it what? U substitution. So I have to make what? Dx the subject. Now this one is over 1, right? So if you want to make dx the subject, we do cross multiplication. Du times 1, we get what? Du, which must be equal to x times negative e to the power x, we get what? Negative e to the power x dx. Alright, so now let's see. Du equals negative e to the power x dx. So this one is over 1. So now, what can we do again? We want dx the subject. So we have to divide both sides by what? Negative e to the power what? X. So I divide both sides. So I get du over negative e to the power x equals what? Negative e to the power x dx divided by negative e to the power x. So this guy cancels, this 1 2 cancels. So I get my dx, which must be equal to now du over negative e to the power x. We know that here is 1 already, right? So I get the same thing as negative 1 over e to the power x du. So in place of the x, I'm going to substitute this guy, which is negative 1 over e to the power x du. So now we still have our integration there. Let's go back to our integration. So integral e to the power x square root of, now I said u must be equal to 1 minus e to the power x. So in place of 1 minus e to the power x, I substitute in what? U. So I have my integral e to the power x. We have our square root, don't forget, square root of what? U. Then times x is what? Negative 1 over e to the power x du. Right. And you can see that this guy can cancel that guy here. So this away. Right. So we get our integral, square root of u times negative 1 du. Now I told you that du means what? With respect to what? U. And here there is no u, which is what? Negative 1. It's a value. So that means we treat this guy as a constant. So a constant, we have to bring it out. So I bring this negative 1 out. So negative 1 integral square root of u du. So we get it as that. And square root of u, you can write it as what? So I have negative 1 integral square root, you can write it as u to the power what? Half. That is u. So we have this. So let me clean this place. Let me clean this place. So kindly follow carefully. So I have that negative 1 integral u to the power half du. Now we can integrate, which is very, very simple. Let's see how to integrate. If I have x to the power n, how do you integrate? You just add 1 to the exponent, then we divide by the total exponent, which is n plus 1. So if you have something as 2x to the power 2, now you just add 1 to that, then you divide by the total power, which is 3. So I get 2x to the power 3 divided by 3. So which is very, very simple. That's the basic integration you have to put inside your memory. So now the same thing, I have negative integral. So let's start the integration. So negative. So don't forget that this negative or negative 1 is affecting the whole of that. So I have u to the power half. I have to add 1, then I divide by half plus 1. You get 2, 1, 2 plus 1, you get 3. So 3 divided by 2. Now, don't forget that we are dealing with an indefinite integral. So don't forget that we have to add our plus c. Our plus c. So now let's go. So let's just simplify this guy. So 1 divided by, we have 1 divided by 3 over 2. And 1 divided by 3 over 2, 1 times 2 over 3, then you get 2 over 3. So you get 2 over 3. Then now, u to the power what? 3 over 2. So we have something like that. So negative 1 times the whole of that, we still have what? Negative 2 over 3. Then u to the power 3 over 2. Then our plus c. The reason why we bring plus c is because we can get any value, constant or whatever, right? We can get, if we were to have, let's say, our limits or our bond or our boundaries there, then we can forget about the what? The plus c. Then that means we are integrating in a what? On an area, right? We are integrating that on an area. Always when we are doing the integration, that means we are finding for an area. We are finding for an area. Always integration, we are finding for an area of that. So now let's go. So now, let me clean this place. So we have negative 2 over 3, u to the power 3 over 2, then plus c. Now, we know that, but our u is 1 minus e to the x. So I have negative 2 over 3. Now, u is 1 minus e to the x, 1 minus e to the x, then 3 over 2 plus c. So don't forget, that's an indefinite integral. Now, or you can still write this guy as negative 2 over 3. Now, this one is 3 over 2, which means that I have it as 3 times what? 1 over 2. And this 1 over 2 can be written as what? Square root. So I have square root of what? 1 minus e to the x, then minus 3 or to the power 3, then plus c. So this is the perfect integration. That's the perfect integration. That's the perfect integration. So integration, which means that if you have something like this, my x, my y, then let's say you have something like this. You are integrating when they give you the limits, negative 1, 1. Then here, let's say here is okay, let me change it 2, then 3. 2, then that means here is 2, then yes 3. Then that means you are finding for the area. You are finding for the area. That's what I mean. The region here, what will be the area for this region? Very, very simple. That's what I was trying to tell you. So that means you are looking for this range, the region, the area between that. So now that's the integration. Very, very simple as that. So now let's proceed to question 1C. Question 1C. So question 1C, it says what? Solve log x squared equals log x all squared equals log x all squared. So now let's see how best can we solve this question. How best can we solve this question? So I have log x squared equals log x all squared. Let's see. Now they are all in base 10. Don't forget base 10, base 10, base 10, base 10. Now, if you have something like this, if I have log x base 10 to the power n, this one you can bring it down, right? Then I get n log x base 10, which means that n is multiplying the whole of what? Log x base 10. So we apply the same property here, or the same rule. So this 2 comes down, so we get 2 log x equals log x base 10 all squared. Now this 2 means what? It's affecting the whole of log x base 10. But this 2 is affecting only x. Get it clear? This 2 is affecting the whole of log x base 10, which means that it is log x base 10 times log x base 10. Likewise, if you have something like this, a plus b all to the power, let's say 3. It's the same thing as well. A plus b, then times what? A plus b. So that's the same idea. So now, how best can we solve this? Then, why don't we represent a variable by log x base 10 so that we can move smoothly? So now we see that let log x be equal to, let's say, m. So I have 2 is multiplying log x, so I get 2 times m equals this one is m. Then don't forget 2. So I get 2m equals m squared. Right. So I send this 2m to the right hand side because I'm getting a quadratic. So I get 0 will be equal to m squared minus 2m. 2m squared minus 2m equals what? 0. Right. What can we do? We can factorize m out. We can bring m out. So we get our m out. This one is m squared. So I have another m. Minus my what? 2, because m is what? Out. Equals 0. So now this m must be equal to 0. So I have my m being equal to 0. And this expression, m minus 2 must be equal to 0. So I get m equals 0 plus 2. So I get m equals 2. Right. So now you can see that hence the values. No, sorry, I'm not done. We are not done. We are supposed to find for what? X, not m. So now we are not done. We have to proceed. We said that what? Let log x equals what? M. Let log x equals m. So we have to say that but log x equals m. So now we can log x equals, what is m? My m1 here, then my m2. m1 we have 0. So now this one is in base 10, right? So we can change it to indices. So I get x being equal to 10 to the power 0, and x being equal to 10 to the power 0 gives 1. Also, log x base 10 equals, let's see what? 2, right? So I get x equals 10 to the power 2, and x equals 10 times 10, and x must be equal to 100. So therefore, or hence, the values of x is what? 1 and what? 100. So 1 and 100. So that's how best we can solve this guy. So always don't forget. See, it skipped my mind. So don't forget. If you have let log x be 10 equals m, don't forget that we presented log s towards m. So this one is not your final answer. You have to proceed there. You have to find for your All right, we'll end here. Then we move on to our next video, which is what question 1D. Solve question 1D in our next video. So stay tuned and kindly subscribe to Massa Tutorials. If you have any problem, kindly drop it at the comment section and I'll attend to it shortly. Thank you and have